Hello everyone, this is Luboš Pirkl from CFD Support and I would like to show you today the train aerodynamics in TCAE in like 20 minutes. So let's try to do that. Let's try to do a complete setup of virtual tunnel simulation of such a train and let's see how we can do it. Let's start completely from a scratch, and we should finish somewhere here. Okay, so I will start from a scratch. So I will open, yeah, I will open a fresh window of TCAE. I'm sorry, give me a second. I need to make sure I will open it on the background. Okay, so this is the fresh screen of TCAE, and I will start building the model. So first of all, you need to create a project. So I will create the new project. I will create an empty project, and I will save it, and I will call it let's say train simulation video. And I'll start building things around. So you have to have the surface model of the train. So you can get it somewhere or get any other model from the CAD, but you have to start with the CAD model. So I will activate the T-mesh module, which is responsible for meshing, for creating the mesh. So I will open the meshing module and I'll start do the settings around. So in the CFD mesh, in the components, there are a lot of settings, but we can keep most of them default and really focus on the most important ones. I will load the geometry. So I have prepared my geometry of the train. There is the locomotive and couple of these wagons. So and also the tracks. So okay, I will open it this way. Let's take a look. So this is my surface model. So I have loaded it in STL format. So I will take a look at it. I guess I'll switch to something which makes it more colorful. Yes, and so this is my train model, which I will build the simulation around it. So what needs to be done is definitely to set up the virtual tunnel, which surrounds. It's virtual, but it surrounds the model. I'm gonna make the aerodynamics around. So uh, I need to set up the virtual tunnel. Before I do that, I like to visualize a couple of things. So I like to see the grid, to see the dimensions, and I usually prefer having the camera parallel projection in ParaView, which helps me to see things without perspective, because perspective for engineers sometimes is not making a good service. So I'll do the camera parallel, so every point is like perpendicular to the screen, as you know. So it allows me to show my model in with the ruler in the perfect orthogonal projection. Okay, so I'm fine with this. Okay, and I'll start building things around. So first of all, I'll go to the mesh settings, and in properties I will check I will create the virtual tunnel, which is something I need to set up in the components in the CFD mesh setup in T-mesh module. I will start saying that there is the inlet, there is the outlet. Okay, I'll first do the do the walls of the virtual tunnel. So my train starts somewhere at in X direction. Let me see. Yeah. In X direction, it's like 5 meters wide. So I'm fine with. Okay, let's do it. Let's do it 20 meters on the left side and 20 meters on the right side, and minus 50 meters because my direction flow is in y direction and minus y, so that's the cat property which I did, and I will make it like 200 meters long, and I'll make it let's make the squared cross section, so I will make it 40 meters high and minus something minus something. Okay, yeah, and of course, yeah, it's not minus 50, it's 50 and minus 150. Okay, so I have my virtual tunnel built around the model, and now I will also say the flow. Yeah, the flow direction is it's I'm unlucky, it's minus y, but why not? So in the y direction, the flow will be flowing. As you know, it's like the reversal engineering trick that we make the effect of moving train with move. Actually, the train stays at the place, and the fluid flow is moving on it, and it gives us the results which are pretty accurate. Okay, so it's my virtual tunnel. I need to say a couple of things. So for example, the walls of the virtual tunnel are virtual. So I will say I need to go with symmetry wall type. It's kind of boundary condition which says there's no friction at the wall, but the bottom is the standard length. So it's a wall. So we have inlet, outlet, sides, and the top is the symmetry, and we can visualize it, of course. So okay, I'm not gonna do that, and yeah, the rest is the walls. The rest of the model are the walls. Very important settings I need to do is the background mesh, which is the basic cube of the mesh cell. So it will be 2 meters, a cube of 2 meters edge. Every edge will be like 2 meters wide, and I need to also specify. Yeah, this is just an example to see what are my basic cubes. I'm fine with that, and I will also say the internal point will be in the domain to specify what's the inside and what's the outside, and I will keep the point somewhere in the virtual tunnel. I can move it. You can see the coordinates are changing, but I will definitely keep it somewhere inside. Okay, so I guess that's the basic settings, and I did the very, very basics, and now I will save my project. I'm saving the project, and I'm already uh, I can run it. At least I can run the meshing. So I did it. I just did it. So let's see what we did. Of course, we didn't specify the refinements and mesh properties and everything yet, but now I wanted to show you how it works from the scratch. So okay, let's see what we have here. So the mesh is already there, and let's visualize it. Of course, it's the very, very basic mesh, but I'm still we're still available to visualize it. So let's see how it looks. Yeah, it's at the beginning. At the beginning, it's of course very ugly, but I'm sure we will be able to do something about it. So we didn't specify any refinement yet, but we already have this basic mesh, so it's just for our information in the beginning. And now let's make some mesh tuning. So okay, I'll go to the settings and I'll say, what if I'll say the refinement will be one for every wall. Okay, what's this? So the car number one, car number two, locomotive, and the tank and the tracks. The track has also now this. Yes, I'll do that. Let's try it. So I can show you that if I save this and if we again regenerate the mesh, let's see what we will get. It takes a little bit more time, but still on one processor it's a couple of seconds. So let's see what we will have. So the mesh is done. So now you can see that the model is a little bit more accurate, but we are not definitely. So this is how the refinement works. So you refine, and unless you're happy with your mesh, and of course then you can add a lot of other features. But okay, we have this, and let's take a look what else we can do. I think we need to add more power into it. So I will say I will use 32 processors for creating the mesh, and I will yeah, let's make another refinement. So if I say okay, I want to refine even more, so okay, let's make it 4 to speed things up a little bit. Okay, the track can stay like 2. It will be enough. So the minimal refinement now is 1 of the basic cell, and the maximum refinement in the Snappy Hex mesh is 4. So I will again save the simulation and run it. Now I'm running the mesh creation, of course. It's just the mesh creation. And this might okay, let's see. Before, yeah, it's still in the process, so maybe I can show you a couple of other things. So sometimes you might need to use the refinement regions. Okay, now it's done. So again, I will show the mesh. So you can see now the mesh is relatively representative. So I'll keep it for a while. I'll keep it this way, and let's say that we can add the refinement region, which is very simple. So let's add a refinement region. It will be a box around the model where there's even more refinement in the volumes, but not on the surface, but on the volumes. No, this is important. And okay, I'll make it again like 3 meters to the left hand side, 3 meters to the right hand side around the model. And what I will do is like, okay, let's 20 meters and minus 60, and okay, let's make it 6 meters high and 0 something on the bottom. I should say I want to see it. So yeah, show the refinement region. So now we have created such a box where will be a special refinement to the level, let's say 2. Okay, so we have such extra refinement around the model. And again, let's save it and yeah, we made some changes, so the original mesh is skipped because it's not corresponding to the settings. I will say okay. Let's check the settings again. We will add 3 boundary layers to each wall. So just did it, and again I will save the simulation and run it automatically. So the process is being done on the background now, and before it's done, I will activate the new module which does the simulation, which is the module called TCFD. So I'm activating the new settings of TCFD. I have a couple of more options here, and I will do the CFD settings here. Okay, so we'll do it. Let's do that. The simulation type will be definitely the virtual tunnel. In the physics, in the okay, I think I do not need to specify any special options. I will say I need to do a lot of iterations because I want the algorithm to stop when the simulation is converged enough. So I'll say okay, I need to see 2,000 iterations, but we will not reach them because it will be stopped by the convergence check. But let's do that. I want to change the fluid properties. There is the air, incompressible, simulation, turbulence. Let's keep everything default. But in the solver, I will say I want to use 32 processors and second order of accuracy. I think that will be okay. Yeah, by the way, my mesh is already done, and okay, so I will work with this. Let's finish the settings of TCFD. I will definitely need to add some forces because the main result of the external aerodynamics is always the forces and their variations and drag coefficients and everything. So I will add these forces. So I will say okay, all these patches, the car, locomotive, not the track but the tank, yes. I will let integrate the forces acting on them. The lift direction is Z. The drag direction it's important is Y, and also I need to specify what's important is the reference area, which is this. It's it's approximately 5 meters times 5 meters, so it's 20. Sorry, yeah, not this. Okay, reference length is okay, 50 meters, doesn't matter, and reference area is 25, 5 times 5 meters, and reference velocity will be 50 meters per second. I won't keep this monitored. So these are settings for my coefficients and forces, and I will also specify here that I want to stop the convergence as soon as the convergence limit is reached. So I will edit. So I will say okay, there will be force probe and the average yes, average drag coefficient when it reaches tolerance, which is 0.01. Then the simulation is allowed to stop and give me the results because it's accurate at the moment. It's accurate enough for this kind of simulation. There's not so many more things I need to set up. I definitely need to set up the boundary conditions. So at the inlet of my virtual tunnel, I will specify the velocity. I will say it will be fixed velocity, 50 meters per second, and in the post-processing I'm at the moment I'm fine with the default settings. Maybe we can get back to it later. So I will save the simulation and I will run automated run, and let's see what's going on. And yeah, because I did the mesh already, the simulation already started. So now it's simulating. You can follow the residuals, and you can follow so much more quantities. All the quantities can be tracked and followed during the simulation, but I'm not gonna show it at the moment. Maybe a little bit later, because I want to make this video relatively short to show you what you can have in like 20 minutes or something. So okay, so this mesh, which is not very fine, but it's for our let's say education purposes, it's good enough, and it has only about 200,000 cells, which is definitely not much, but for our purposes it's good enough. Okay, we can see that it's already converged, because yeah, the convergence check stopped the simulation and the convergence was reached. And we can look at the results. The simulation report is being generated now. It has been generated, so there is a simulation report where you can follow all the important quantities, and that's at the moment not that important for me. I will take a look at the results, the volume results that may interest you in the very first place. Okay, so there is the volume of the virtual tunnel. I will visualize it with making the transparency, the opacity. Then we can look inside, and what we could do is maybe to show you the simulation mesh in the volume and the pressure results. So I will use some couple of filters. ParaView is great, really great post-processing tool. So I will use this slice, perhaps this Z normal, and I will pick some random. I will pick some random plane where I will be able to show you this plane. We made the cut. Okay, maybe it was too low on the ground, but okay, what do we put it a little bit more up? Okay, maybe this will be better. And again, let's rescale it, and you could do here a lot of really a lot of things. You can make another filter and another filter and filters of filters, and it makes the visual possibilities endless. There are a lot of options what you could do. Maybe I could do this contour. It's usually looks reasonably representative. I will make like 100 intervals, apply them, and say okay, maybe they're not nice. If you show them in colors, I like it. I usually like it like solid color. I'll make it. Let's make them black, and still the slice could tell us how the pressure field has developed around the train. And maybe okay, it's a little bit ugly. I don't like it, so let's move this away. Maybe in this slice I could show you the mesh, because this shows you how the mesh is, what are the proportions in the volume. You can see the refinement box in the volume is around the model. We specified it in the beginning in the settings, and the rest of the mesh is this. Of course, the mesh is very rough, but very good for representative results. You would be surprised how rough mesh can be done and how the results can be good, and they definitely fit trends if you make some modifications. Okay, I will yeah, maybe what's good to show, because ParaView always makes a lot of triangulation. So this is how the is it? Yes, it is. So I need to click apply, of course. Yes. So this is how the mesh really looks like. These are the crinkled complete cells. So you could see how the boundary layer is created around the model, and how is the cascade of the mesh cell sizes. And I'm yeah, what's this? I don't want this. Yes, okay. But this is the slice. The slice is not that important at the moment. What we could do is my favorite stream traces. So the stream traces filter shows you the trajectories of the flow. That I like them all the time. What we could say, okay, I will do the no, I clicked glyph, right? So I don't want, I'll take it back. I don't want the glyph. I want, of course, the stream traces. So it's this filter, and I will definitely go not for the line, but for the point cloud, and this point cloud will be somewhere in the beginning of the tunnel. So let's make it 0, 50, and the height will be not much. Let's put it to your eyesight, so which is 1.5 meters, perhaps. And the size of the point cloud, let's make it 2 meters. Hopefully it works. So okay, maybe let's make a little bit more of the number of points. Let's make 500. And these are stream traces around the model, and let's color them with the velocity field. And I always like playing with display, so let's make them only like 0.2 visibility, but let's make them more width. Let's the width make like 5, and let's render them as tubes. That's what we can live with. Okay, so this is I can visualize the original model, and so this is you can see this is the basic visualization. I need to, okay, I don't want to, I will make sure, okay, this out, and also let's scale the things by the stream traces. So what we did is the very basic simulation setup, but we have the results here. We can look, for example, let's open the new line chart view where we can take a look at the quantities, how the quantities developed. I would like to see the average drag coefficient and the actual in instantaneous drag coefficient, how they developed in time during the simulations, and you can see the yeah, the convergence was pretty good, and yeah, after a certain time it was stopped by the convergence check, so everything seems to be okay. Also the value 0.5 is let's say typical. So yeah, I think perhaps this would be it. So I just wanted to show you how simple it is to set up a simulation from a scratch in a good CFD software, of course. So it's this, it happens, and I guess yeah, this would be it. So thank you, and bye bye for now. Bye bye.